Integrate cos square x upon cos square x plus 4 sin square x with respect to x. With reference to these various types, let's now try to integrate this new function. To integrate, let me first divide throughout by cos square x, numerator as well as denominator, which makes the numerator just 1. Denominator cos square x by cos square x is 1, sin square x by cos square x is tan square x. A simple function. But what is the use? If we take tan x as a substitution, there should have been sec square x in the numerator as the derivative. Only then the substitution is valid. If sec square x is not available, why not we make one? Multiply and divide by sec square x in order to have a derivative. Tan x derivative is sec square x. We created it. But during that process, to balance, we had to divide by sec square x also, which has come extra. What do we do with that? There is a way out. Change this sec square x again in terms of tan x. 1 plus tan square x is sec square x. It's an identity. And the numerator sec square x, let it be as it is, which we have already planned as the derivative of tan x. So our substitution now is u equal to tan x, so that du is sec square x dx. The numerator is du and tan x will be replaced as u. So 1 upon 1 plus u square into 1 plus 4u square. The whole trigonometric function is now changed into a rational function, polynomial upon polynomial. Now, this kind of rational functions are integrated with the help of partial fractions. But what type of partial fraction? It depends on the type of denominator given to us. What should we split it up into? The method says when the denominator factors are second degree non-splittable ones, which we have right now. 1 plus u square cannot be split, no factors. 1 plus 4u square also cannot be factorized. Then we should be taking corresponding to each of such factor, a first degree polynomial should be taken in the numerator for non-splittable quadratic. But observe that though this is non-splittable quadratic, neither in the denominator nor in the numerator there is any u present, first degree, not present. So it is sufficient to take just two constants like this also. We can do by this shortcut, reason I already said. But if you still feel you have to go by this method, it's okay. You can assume this numerators. But what is going to happen is, while solving for a, b and c, d, the coefficients of a, that is coefficients of x, that is a and c, will become 0. And you will eventually get b upon x square plus 1, which is a constant upon second degree, and d upon the second one. This is the way it is going to be. So then why not we go by this shortcut, just take the constants. Why to have the hassle of solving for all four, though it's not wrong. We can go by that also, but I'm choosing this. So I proceed further. To find the values of a and b, let me take the LCM. The product of the denominator is the LCM, which will cancel with the LHS LCM denominator. So the numerator 1 would be equal to a into 1 plus 4u square plus b into 1 plus u square. Now, this polynomial equation is going to be true only if the coefficients of like terms are equal. What are the coefficients of like terms? Constant term a into 1 and b into 1. So a plus b will be the constant term on the RHS, but on the left side the constant term is 1. So 1 is equated to a plus b. Coefficient of u square 4a and b. So 0 is equal to 4a plus b. Why 0? There is no u square on the LHS. Now two equations we have to solve for a and b. I would solve for this a and b and get a equal to 1 by 3 minus 1 by 3 and b equal to 4 by 3. So, this single integrand now can be rewritten as two different terms with the help of the calculated a and b's, minus 1 by 3 and 4 by 3. So, two terms, two separate terms, minus 1 by 3 upon 1 plus u square plus 4 by 3 upon 1 plus 4 u square. Now, we will be able to integrate them separately. Let's write them separately during that same time and taking the coefficient of the u square term 4 out. Divide by 4. So 1 by 4 will come out here. So this 1 will become 1 by 4. Why is it done so? You will see it soon. Because both of them are now going by this formula. Integral of 1 upon x square plus a square, for which the coefficient of x square should have been 1. That is what I made by dividing by 4. And moreover, this 1 by 4 can be written as 1 by 2 whole square. That will act as a square. So both of them follow the tan inverse formula. 1 by a tan inverse x by a. Here a is 1, here a is 1 by 2. So minus 1 by 3 is the coefficient. Tan inverse u by 1, that is tan inverse u. Then 1 by 4 by 3 is the coefficient. Then 1 by a. 1 by a is 1 by 2. 1 by a tan inverse u by a. Simplify further, u by half is 2u. This is simplified to be 2 by 3. Minus 1 by 3 is the coefficient here. Minus 1 by 3 tan inverse u plus 2 by 3 tan inverse 2u. Integration is over. But we need to replace the variable u that we brought in. Put back. Tan x is to be put back. What is tan inverse u then? Tan inverse u is x. So this first term will be simply an x. So minus 1 by 3 into x plus 2 by 3 into tan inverse of 2 into tan x. U is tan x plus c because of the integral constant of integration. Found it useful? Don't forget to subscribe Mariette Joseph channel for variety of examples and various topics.